Okay, an introduction to integers. Okay, so an integer is a number that falls in this set. Okay, the leading in, the dots that lead in, and the dots that lead out, okay, those mean that it continues in the same pattern to the left and continues in the same pattern to the right. So, continues in the same pattern to the left and to the right. Okay, so you just have to think to yourself, well, does the number I'm thinking about would it fall in this number set if I continued these on forever in both directions? So like 102. Okay, if you continued on to the right for quite a while, you would actually end up writing down the number 102, because we're writing down every whole number to the right. Okay, and then we're writing down all of their additive inverses to the left, so the numbers that have the opposite signs of them are on the left-hand side of 0. Okay, and those go on forever. So negative 102 would also fall into this set. Okay, let's look at how these look on a number line. Okay. Oh, I don't like that. Let's put some ends on it. So it actually looks like a number line. We need those arrows anyway, because that tells us that it continues on forever. Okay, so if we were going to write the set of integers, we might write it something like this. Put the number line on there first. And we'll get the negative 6 on here to make it evened up. Okay. Okay, so we're going to put a dot above each number that falls into the set of integers, or a dot on each number. So 0 does, 1 does, 2 does, okay, and 3 it says it does. Okay, now I have to make a decision. Does 4 follow that same pattern? Yeah, the pattern is that we add 1 each time. Okay, so 3 to 4, that's adding 1. 4 to 5, that's also adding 1. And 5 to 6, that's adding 1. Okay, and now we'll come back to, well, no, we can do that right now. We have the ellipses dots, or these dots up here that say it continues on in that direction. Well, we need to signify that on our graph. Okay, so on our graph, we're going to bold in this arrow over here to tell people that the things that we're graphing continue to take that pattern to the right. Okay, that tells us the same thing as those 3 dots. Okay, now let's go to the left-hand side of 0. Negative 1 is up there. Negative 2 is up there. Negative 3 is also up there. Does negative 4 follow the same pattern? Well, to go from negative 1 to negative 2, we subtract 1. To go from negative 2 to negative 3, we also subtract 1. Remember, every time you move to the left on the number line, getting smaller, you're subtracting 1. Just getting smaller and subtracting go the same hand in hand. Okay? So negative 3 minus 1 is negative 4. Negative 4 minus 1 is negative 5. Negative 5 minus 1 is negative 6. And I'm going to try to undo. I'm going to try to extend this line just a little bit so that all fits on there. Okay? Negative 5 minus 1 is negative 6. And then we need to signify that this continues on forever over this direction. Okay? So these are the set of integers. Okay? They're numbers that we use all the time. Okay? Best or one of the most common representation is on like a thermometer. Okay, so if we say that the temperature is 92 degrees, you're used to seeing that as a positive number. Sometimes in the dead of winter, like this last harsh winter, we might see temperatures like this, -5 degrees. Okay, so we know we went past 0, and then we went 5 more degrees to the left. Okay, so those are just some examples of integers and their use in the real world.